Below is the phase plot for an autonomous differential equation. dy by dx is equal to some g function of just the output y. That's what makes it autonomous. If we've got a particular solution to this dE that satisfies y at 0, so when x is 0, y is going to be equal to 6, evaluate the limit as x tends to infinity of this y solution. Okay, so what do we do? So the long-term behavior for an autonomous dE, the long-term behavior is either it's going to go to infinity, negative infinity, or it's going to tend to one of the equilibrium solutions. And on a phase plot, those can be found as just the horizontal intercepts. They're where the rate of change, which is represented vertically, is equal to 0, so right on the axis. Okay? And we can see, the question isn't asking us for this, but negative 1, 4, 8, let's see, negative 6. So those are the equilibrium solutions. So it's those, or maybe it'll spiral off to infinity or negative infinity. All that matters is where this initial y value is. Okay? Sometimes people think it has something to do with the x value, the input, the independent variable, but no. The autonomous dEs are kind of known for basically disregarding the independent variable. Right? And it really has nothing to do with it, with almost any of the behavior at all. So it's really just about y. So we start with y is 6. Okay? And we're going to run into one of the equilibrium solutions. Since we're between 4 and 8, if somebody came along and said, oh, you have to guess, I'd guess one of those two. But we can know for sure by drawing in arrows that represent the increasing or decreasing behavior. So based on the vertical information, the rate of change, so positive curve, that represents increasing for the value of y. So that would be moving left. So we get increasing behavior anytime the plot, the curve that we've got, is above the axis, the horizontal axis. And anytime we're down below, that would represent negative derivative. So the y value should be decreasing, and decreasing means moving to the left. Right? 8, you move down to 4, down to negative 1, you move to the left when you're decreasing. So you say, all right, we start with y is equal to 6, the x value has nothing to do with it, and then you just follow the arrows until either they go off the page or they run into an equilibrium solution. One of the two will happen, and we can see, oh, starting at 6, looks like the curve, the solution will decrease. The dy by dx values are negative. Decrease, decrease, decrease until you tend to. You won't actually get there, but you tend to 4. So that is going to be our final answer. As the x values increase, as we follow the function along, the y values, the outputs, will slowly get closer and closer to 4. Specifically, they will, if somebody wanted you to clarify, you could say they decrease towards 4. So it's not just that we're going to 4, but y will be 6, and then eventually it'll be 5, then it'll be 4.5, then it'll be 4.1, then it'll be 4.00000002896. It'll specifically be heading to 4 by decreasing over time. Okay? But the question just asked us for the limit, so there it is. There's our final answer, and we're good to go.